midpoint to midpoint instead of midpoint to vertex. So you, in a triangle, what I like to do is, the cleanest way to do this is 3 circles. And if you work on the biggest side, if I make 3 circles, I can get all 3 perpendicular bisectors of the sides, but I'm not going to draw on the perpendicular bisectors, I'm just going to put in the midpoints. So if I take the largest side and make a circle, so this goes more than halfway of the largest side, do you see that? So I'm going to switch the color of the circles because it is kind of hard to see with all one color. So even though I'm not switching the compass size, so I've gone to all 3 vertices, and I'm drawing 3 circles, okay? Then I'm going to use, like I said, you guys would try to use your ruler, but let's see if I have a little more luck, your straight edge. So because I want to get the intersection of, say, the red and blue circle, right here. Do you see that? Whoops. So they're pretty close there. And then you would draw that in just with a pencil. And that yellow intersects in a midpoint. I also did a perpendicular bisector, but I'm not using the perpendicular bisector in the end. You see, this would be like my first midpoint, M1.
So on your homework, you want to see.
So I want to see everything, right? So there's my first midpoint. And then I would go to, say, the red and green. See how it doesn't like stay put? That's what's hard. That's pretty good, right?
Yeah.
So again, I'm doing this in yellow just so you can see. Even though that's the perpendicular bisector, what I'm really interested in is the midpoint. So this will be M2. So that's a midpoint. And then I would do the third one. So I keep moving that. I need to get the green and blue circles. Can you kind of see that? So pretty good. So then when I move that out of the way, this is M3. The mid-segments are when I connect them. There's a mid-segment, there's a mid-segment, there's a mid-segment. So there's 3 mid-segments. When you connect any 2 midpoints, that's a mid-segment. If I connect, if I make all 3, you should see that triangle within a triangle.
So what's that called? That triangle?
Yeah, what do you notice? And what does it look like?
Upside down.
What? Well, what do you know about the triangles? You know, they're congruent. Turns out they're congruent. It makes 4 congruent triangles.
4.
Well, yeah, 4.
Oh, I just saw that.
Where?
Oh, yeah.
Watch. So here's one.
Oh.
Oh, that didn't. Okay. Here's another. Didn't hit it perfectly, right? But see that? And then if I say copy this one, it fits in right there. You see that? Yeah. This one I didn't do a great job on, so let's cut it out and copy this one.
Next slide.
Makes 4 congruent ones.
But it makes it.
What's that middle one?
The big one.
Getting there, but that's 4.
And
So-
And the big one.
Congruent, you guys. We're talking about congruent
Oh.
triangles, right? So this 4th one, when I rotate that, it should fit in there, right? And it turns out they're congruent. I mean, because I just used the same triangle over and over and over. I didn't make new ones. Awesome.
Yeah, they're all similar to the bigger ones. So if you like-
Then they're all similar to the big one, to the 5th one. And their ratio is 1 to 2. Right. Right. And all of that comes into play. Okay, so those are the constructions for today. Segment construction.